Okay, in this video we are going to work through the creation of a logic circuit. So the way you do it is you focus first on this part of the question, okay, when it talks about the different conditions. And I'm going to rewrite this out on the page just so we've got something to refer to. I'm going to say that x is equal to 1 if oil pressure, which is parameter P, is greater than or equal to 3 bar, so that's there. So if P is 1, okay, so say if P is 1 and temperature is greater than or equal to 200 degrees, so that's T is also 1. Okay, so that's the first line done. The second line's OR. And then we're saying that the oil pressure is less than 3 bar. So that P is 0. Okay, so we can write it like that. P is 0. And we're saying that the rotation is greater than 1000 RPM. So R is 0. That's the next line done. Third line starts with an OR. We've got temperature greater than 200 degrees, or greater than or equal to 200 degrees again. So that's T equals 1. And the rotation is greater than 1000 RPM, which is R equals 0. And that's the third line done. So if you ever see something like P equals 0, R equals 0, this indicates that these things should pass through a NOT gate, because if you remember from what I said in class today, you have to assume that all the inputs start as 1. Okay, so P is 1, T is 1, and R is 1 when it comes in from the left hand side. So to change any of those to 0, you have to put it through a NOT gate. So before we start drawing this, I'm just going to put brackets around each of the pairs. Okay. And this will hopefully help us. Now there's not a central point here because there's 3 lines. Okay, so there's three conditions. So I'm not going to start with the right hand side of the logic gate this time. If there was 2, then we could focus on OR being the center. So we're going to focus on the left hand side. So we're going to start with the first line, which is P equals 1 and T equals 1. And so we just draw an AND gate, and we take T and we feed it in, and we take P and feed it in, and that is our first line complete. I'm just going to tick that off in a different colour. We then have to deal with the next part, or the next line, and this is the stuff in brackets. So P equals 0 and R equals 0. So we've got P and R, but they're both going through a NOT gate. Okay, so we've got P and R. So R coming through a NOT gate, and P coming through a NOT gate as well. I'm just going to put it down here. And they're then linked together with an AND gate. So that is the part of line 2 that's in brackets. We then have to link the first expression with the second expression using an OR gate. So we take both outputs from the AND gates and we feed it into an OR gate. And then I can tick off that line because we've completed that line. Now you might notice that my drawing is pretty rubbish. So if you ever find yourself in a situation where you're not sure if it's clear what the gate looks like, you can annotate them just by writing either inside or next to each of the diagrams. Okay, so far we've done 2 lines. We need one more line, and this is where we're going to focus on what's in the brackets. So t equals 1 and r equals 0. So t equals 1 comes in. I'm just going to split off here and jump over. Okay, so t equals 1, and we're going to link it with r being 0. Now, luckily, we've already got a NOT gate. So I'm just going to take it up here. And I'm going to feed both those inputs into an AND gate. And just to keep it consistent, I'll write AND gate above it. We're then left to link what came before with the expression we've just sketched using an OR gate. And so this is where the output from the OR gate and the output from the AND gate get combined together in that OR gate here. And because we've now completed all 3 lines of the expression, you can take the output from the OR gate and pass it out to x. Okay, hopefully that helps.